Hi guys, welcome back. Today's topic is Dijkstra algorithm. So in this video I am going to discuss with you the working principle of Dijkstra algorithm and then what are the drawbacks of this algorithm. Okay, so Dijkstra algorithm is basically single source shortest path problem. Single source shortest path problem. See, the name suggests single source. In this algorithm, one source is given. You are supposed to ask to find out the shortest path maybe, and you are supposed to consider maybe 0 as a source vertex, and from 0 you are supposed to find out the shortest path to all the vertices, or maybe you are supposed to ask 2 is the source and you are supposed to find out the shortest path from 2 to 1, 2 to 4, 2 to 8, 2 to 5, 2 to 6, like that to all other vertices. So it is basically single source shortest path problem. From one source you are supposed to find out shortest path to all other vertices. Okay. Now we will discuss the working principle of this algorithm, and after that I will show you the drawback of this algorithm. Okay. See, suppose this is your graph and you are supposed to find out the shortest path, and source vertex that is given to you is 0. 0 as a source vertex. Maybe you can consider 5 as a source vertex and start your algorithm. You can consider 8 as source vertex, or maybe in question you are given 6, consider 6 as a source vertex. Then you are supposed to consider 6 as a source vertex, and then you will start the algorithm. But here you will consider 0 as a source vertex. Okay. Now, first step is just mention the distance of this all these vertices from this vertex. See, we can easily say the distance of 0 to 0, this source vertex to source vertex. 0 is source vertex, that is why I am starting from this. I am starting our algorithm from this vertex only. So from 0 to 0 distance is 0, and at first step the distance of all other vertices would be infinity, 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 like that. We don't know what is the distance, what is the shortest path. Okay. Now let us start. We are going to start from 0. From 0 to how many vertices are directly connected? This 1 and this 4. So we can find out the distance from 0 to 1 and 0 to 4. Okay. Now how this distance is to be calculated? Like this. Suppose we are considering 0 to 1, we are calculating this distance. So we will consider 0 as u and 1 as v. So what is the formula? See, this is the formula. Distance of u plus cost of u to v, and next we have distance of v. See, distance of u, here we have 0 as u, so distance of u is 0, plus cost of u to v, v is the destination, from 0 to 1 we are going to that find out the distance na. Here v is 1, the cost of edge u to v, what is that cost? That is 4. Okay. And distance of v is, starting may we don't know what is the distance of v, that is because this is infinity. So distance of v is infinity. So the formula is, if distance of u plus cost of u to v is less than d of v, in that case what happens? You see, in this case 0 plus 4 is 4 and 4 is less than infinity. Okay. So we will update this infinity to 4. We will change this infinity and we will write here 4, because 4 is less than infinity. Fine, and obviously we are calculating the shortest distance. So if this is true, then what happens? The distance of v, distance of v को हमने change कर लिया, and distance of v क्या हो गई है अपनी? Distance of u plus cost of u to v. This is the main formula to calculate the shortest distance. Okay. Now again find out from 0 to 4. Here this one is 0 now, sorry 0 is u, and now v is this 4. Okay. Now from 0 to 4, what is the distance? Distance of u is 0, 0 plus cost of this u to v edge is 8, 0 plus 8 is 8, and 8 is less than infinity, that is why we update it and we will write here 8. Okay. Now this vertex is now selected vertex, or you can say visited vertex. We have selected this 0. Now next is, now check, this vertex is already selected, we have already find out the shortest path from 0 to 1 and 0 to 4. Okay. Now this one is selected, just leave it. Now check out all the remaining distance. This one is 8, this one is 4, and every other distance is infinity, infinity, and infinity. Now select the shortest distance. Shortest distance out of these is 4. Okay. Now we will select this vertex. This vertex is now selected. Okay. Now see, this vertex is now selected. From this vertex, we can update this distance from 1 to 2, we can update from 1 to 4, and we can go from 1 to 0, but we will not update this distance. Why? So because 0 is already selected. So once a vertex is already visited or selected, we will not update the distance of that vertex. Okay. So from 1 we will update this distance and this distance, and when you will update, if this du plus cost is less than, then only you will update. Now find out from 1 to 2. Now in this case, this is u and this one is v. Now find out this distance. Distance of u is 4. 4 plus cost of u to v, cost of u to v is 8, and distance of v is infinity, and this one is less than infinity, in that case we will update this distance. So rather than this infinity, we will write here what? Distance 4 plus 8 is 12. Okay. Like this we will find out all other distances. Now from this to this, find out. Distance of u is 4, 4 plus 11 is 15, and this distance of v is 8. Okay. But 8 is less than this 15, so we will not update this distance, because if this plus is less than dv, then only we will update this. But 11 plus 4, 15, 15 is greater than 8, then we will not update this one. Okay. Now this is already selected, 0 is already selected, we will leave these nodes. Now out of remaining nodes, which node is having the shortest distance? 8, infinity, 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 12 and infinity. 8 is the shortest. Okay. 8 is less than or you can say the least distance, you will select this 4. Okay. We will select this one. Now from this vertex we can update the distance of 4 to 5, 4 to 8, 4 to 1, 4 to 0, but 4 to 0 and 1 will not update because 0 and 1 are already selected, or you can say visited. Okay. So we will not update distance of these vertices, we will update 4 to 5, 4 to 8 only. Now find out this distance 4 to 5 distance. Now here this one is u and this one is v. Distance of u is 8 plus cost of u to v is 1, and this distance of v is infinity, and this one is less than infinity. 8 plus 1 9, less than here, then we will update it. This one is 9. Okay. Now find out this distance. 8 plus this cost is 7, 7 plus 8 is 15, 15 is less than infinity, so we will update this distance. Okay, this one is 15. Okay, now we have already updated. Now this one is selected, this one and this one. Now leave these nodes, and out of these remaining nodes, which node is having the shortest distance? 9, 15, 12, infinity, infinity, infinity. 9 is the shortest one, then we will select this 9. Now 5 is selected vertex. From 5 we can update 5 to 6, 5 to 8 distance. Okay, we will not update 5 to 4 because this one is already selected. Okay. Now find out this distance 5 to 6. This one is now u and here now this one is v at this time. Okay. 9, distance of u is 9, 9 plus 2, 11. 11 is less than infinity, we will update this. Okay. Find out this distance. 9, 9 plus this cost is 6. 9 plus 6 is 15, already 15, no need to change. Okay. Leave it. Any other? We cannot update. This one is already updated and only 6 and 5 are directly connected to the selected node. So, we have already updated this 11 and this 15. Okay. Now, just leave these selected nodes and out of this unvisited nodes, which is having the shortest distance out of 11, 15, 12, infinity and infinity. 11 is the shortest, so select this one. Select 6. Okay. Now, from 6 we can update the distance of those nodes which are directly connected, that is 7, 3, 2. We will not update this one because this one is already selected. Okay. We will not visit this vertex again. You can say it is already selected or visited. From 6 to 7, now this one is u and this one is v. Find out this distance. Distance of u is 11 plus 10, that is 21. 21 is less than infinity, we will update this. Okay, this one is 21. 11 plus 14, that is 25. 25 is less than infinity, we will update this. That is 25. Okay. This one, update this one also. Check out 11 plus this edge is having distance 4. 11 plus 4 is what? 15. Fine. But here 2 is already having 12 and 15 is greater than 12, so we will not update this distance. This will leave it as it is. Okay, we will not update this one. Any other you can update? No. Okay. Now, out of this 4 unvisited nodes, which is having the shortest distance 15, 12, 25 and 21. 12 is the 12 is the minimum distance. You will select this 12. This node will be selected. From this node, you can update this distance and this one. We cannot update this one because 6 is already updated, already visited. We cannot update this distance because 1 is already visited. Find out from 2 to 8. Now, this one will act as u and this one will act as v. Distance of u is 12. 12 plus 2 is 14. And distance of v is 15 and 14 is less than 15, so we will update this one. This one will become 14. Okay. Now, next is update this one also. 12, distance of u is 12. This cost of this u to v is 7. 12 plus 7 is 19 and 19 is less than 25, so we will update this one. This would become 19. Okay. Now, we will not update this one, we will not update this one. It's done. Now, out of these 3 unvisited nodes, which is having shortest distance, this one is having 14, this one is having 19, this one is having 21. Then we will select this 14 because this is having the minimum distance vector. We will select this 8 now. From 8, you can how many nodes are directly connected? This 5, this 4, this 2. But we will not update this or this distance because 2, 4 and 5 are already visited. Okay. So, we cannot update distance of any other node, 3 or 7 ka you cannot update from this 8. Leave it as it is. Okay. This one is selected. Now, out of these 2, which one is having the shortest one? Or you can say the minimum distance vector, that is 19 and 21. 19, then you will select this 3. 3. You can update this distance only because these 2 are already selected. Then 19 plus 9. What is this? 28, I guess. 28, but 21 is less than 28. So, we will not update this one. Okay. Now, only one node is there. We will select 7 only and this one is 21 only because we will not update these distances. Okay. So, using this formula, this is the working principle of Dijkstra algorithm. Okay. See, if I ask you what is the shortest distance from 0 to 3, then the answer would be this 19. What is the shortest distance from 0 to 8? Then the answer would be 14. What is the shortest distance from 0 to 6? That is 11. Shortest distance from 0 to 7, that is 21. From 0 to 5, 9. From 0 to 4 we have 8. From 0 to 1 we have 4. From 0 to 2 we have shortest distance is this 12. So this is the working principle of Dijkstra algorithm. Now see, this Dijkstra algorithm works on undirected graph and directed graph as well. Okay, now we will take one more example of directed graph. Okay. Now let us say we have this graph, which one is directed and weighted graph, and we are supposed to find out the shortest path from the source vertex, and source vertex is A to all other vertices. Okay, let us suppose A is source vertex. Maybe in question you are given that consider C as a source vertex. Okay, now in the previous case we have already updated the distance in this graph only, but in this case I will draw one table and we will update the distance in that table only. Okay, see, now we will draw a table A, B, C, D and E. These 5 vertices we have. Starting में you will write that vertex which is the source vertex. Suppose in question you are given consider B as a source vertex. Okay, in that case you would have written here B, and here you can write A, C, D and E like that only in any order, but the source vertex must be written in at first only. Okay, here we have considered source vertex is A. Fine. Okay. Now the very first step is just the same thing we have already done in previous example, that 0 to 0 distances, sorry, A to A distance would be 0 and baki other remaining distances would be infinity. So the distance of this one is 0, this one is infinity, infinity, infinity and infinity. This is the first step. Distance of source to source would be 0. Okay. Now out of these, which one is having the minimum distance factor? That is 0. Okay, so we will select this, 0 and the vertex is A. Okay, now from A to how many vertices you can find out the distance? A to B and A to C. See, there is no that edge from A to E, this edge is from E to A. So we cannot update from A to E, we can update only A to C and A to B. Now find out the distance from A to B. Distance of A is 0. Same formula, distance of U plus cost of U to V and distance of V. If this one is true, then we will update distance of V to distance of U plus cost of U to V. Use this formula only. Okay. Now find out from A to B. Distance of A is 0, 0 plus this cost is 10. Okay. And 10 is distance of B is what? Infinity. 10 is obviously less than infinity. We will update here 10 only. What about C? A to C. 0 plus 5 is less than infinity. We will update here 5 only. D we will not update, to E we will not update because there is no direct edge from A to D and A to E. Okay, this one is done. This one is already selected, we will not write this in another the next row. Now out of these 4, which one is having the minimum distance factor? That is 5, 10 or infinity, that is 5. Then we will select this 5. Okay, that is C. C vertex has been selected. Now from C we can update distance of C to B, C to D and C to E. Okay. Now find out the distance. C to B. What is the distance? Distance of C is what? This 5. Okay, see, we have selected this 5. So we will consider this distance. Distance of C is now 5. You can say distance of U is 5. 5 plus distance of C to B. What is this coast of this edge is 3. 5 plus 3, that is 8. And distance of this one is distance of B. Now here B is B. Distance of B is what? 10. And this 8 is less than 10. Previously see it was 10 previous. Okay? But we have selected C, and through C if we go to B, A to C then B, then what is the distance? Distance of C is 5. 5 plus 3 is 8. So 8 is less than this 10, so we will update this. Here we will write 8. Okay. Now next, from C to D, distance of C is 5. This coast of this edge is 5 plus 9, that is 14. And previous it was infinity, and 14 is obviously less than infinity, so we will update this. From C to E, what is the distance? Distance of C is 5. 5 plus 2 is 7, so we will update this. Okay. We will not write this 5 again because we have already selected this 5. Okay. Now out of these 3, which one is minimum? That is 7. We will select this vertex, that is E. E would be selected. Now from E we can update the distance of D and distance of A, but we will not update this distance. Why so? Because A is already selected. These are selected vertex, or you can say visited vertex, or you can say marked vertices. Okay. Now E to A will not update, we can update only E to D because we have edge from E to D. Now find out the distance. E to D, distance of E is 7. Okay. 7 plus this coast is 6. 7 plus 6 is 13, and distance of D is 14 previously, and 13 is less than this 14, so we will update here 13. Now can you update this distance? E, we have selected this E. Can you update E to B? E to B, no, there is no edge. Then we will write as it is here 8. Okay. Now we have only 2 vertices which are unvisited. Out of these 2, which one is having minimum distance factor? That is 8. We will select this 8, and the vertex is B. B would be selected. Then from B we can update only this B to D. Okay, and we have only one vertex that is remaining. Now find out this distance B to D. What is the updated distance? Distance of B is 8. 8 plus this coast is 1. 8 plus 1, that is 9. Okay, and previously the distance of D is 13, and 9 is less than 13, then we will update here 9. Okay, we will not write this one here. And now we have only one vertex that is unvisited, then obviously we will select this vertex. This vertex is D. This is the table through which you can find out the minimum distance. Now if you are asked what is the distance, shortest distance from A to D? A to D. So what is the shortest distance? That is 9. From A to E, 7. From A to C, 5. From A to B, 8. Okay. Now second thing is, if you want to find out the path, suppose we are supposed to find out the shortest distance from A to D plus the path. Okay. Maybe there would not be the direct edge from A to B. We have हमें A to पहले हम गए, maybe B, then C, then D. So you have to find out that path. Okay. Now what is the how to find out that path? Suppose A to D we are supposed to find out. Okay. A to D, shortest distance is 9. We have selected the vertex D here only. Okay. Now one pointer would be set at 9 only. Okay. And here I will write the path. Here I will write the path only. Okay. This 9. Okay. The selected vertex is D. We are supposed to find out the path from A to D only. Okay. This 9 is the shortest distance, and the path is D, we have selected D here only, see D, okay. Then suppose in path I am writing D. Now we will move this pointer one step backward. हम यहाँ पे हैं, then I'll go to one step backward. I'll go here only, okay. And this has been changed. See, पहले इस in this point it was 13 and after that it has changed to 19. So in this case अगर ये change हो गया है तो we will check in this row which vertices has been selected. Which vertices has been selected? This one, and this one is what? B. B has been selected, okay. Pointer would be here only. Now I'll write here suppose B. B has been selected. Then we will go one step backward. Here 8 only, okay, no problem. जब तक ये वैल्यू सेम आएगी you will move one step backward. जैसे ही वैल्यू चेंज होगी, ठीक है, at that point you have to do something. Now go one step backward, here only. It is 10, but next step it was 8. So this has been changed here only, okay. Now in this row जहाँ पे वैल्यू चेंज हुई है, in this row which vertex has been selected, that is this one, 5, C. C has been selected. Then you will write here C. Pointer would be here only. Now go one step backward, okay. यहाँ पे था infinity, यहाँ पे change हो गया है, ठीक है. The same step change हो चुका है, तो you will check in this row which vertices has been selected. This one, 0 जिसकी distance है, and that is A. That is A. We have reached to the source vertex, that is 0. So the path from A to D is A, C, then B, then D. Shortest path, and the distance of this path is, what is this? 9. You can check out in this. You can check out this path through this graph only. See, A to C, what is the distance? A to C, 5. 5. C to B, C to B, that is 3, plus then B to D, B to D, 1. And this one is 5 plus 3 plus 1 is 9. And already we have find out the shortest path, that is shortest distance, that is 9. Same, suppose you have to find out shortest path and shortest distance from A to E. From A to B, suppose. Okay, what is the path and what is the distance? A to B. The shortest distance is, you simply just check this table and you can quickly say that the shortest distance is 8. A to B, and find out in this column what is that selected, that number is 8. So 8 is the shortest path. Sorry, the shortest distance. But what is the path? Okay. Now how to find out the path? Same formula. Just keep a pointer here, 8, because we are supposed to find out the shortest path from A to B. B. This one is 8. You will just set up a pointer here. Move this pointer one step backward. This one is 8 only. No need to do something because 8 and 8 both are same. Go to one step backward. Here it has been changed, 10 and 8. So जहाँ पे ये change हुई है, in that row only find out which vertex has been selected. This vertex, that is C. C has been selected. Okay. The path is B. Then in this one C has been selected. You will write C. Okay. This one C has been selected. Then pointer would be here only. Then one step backward. Here it was infinity. Change हो चुका है infinity to 5. जब change हुआ है तो in that row which vertex has been selected? This one, and this vertex was A. And we have already reached the source vertex, that is 0. The path is A, C and B, and the distance is 8. A, C and B you can find out. 5 plus 3 is 8. So this is the table. You can find out using that table the path as well as the shortest distance. Now the drawback of this Dijkstra algorithm is what? It will not work. See, I am not saying that it will not work. It may or may not work when the edge weight are negative. I'll show you with the help of one example. Okay. Now let us take this graph. Which one is having negative edge weight? That is -10. Now suppose find out the shortest distance. 1 is the source vertex. So 1 to 1, 0, and remaining would be infinity and infinity. Now find out 1 to 2, 0 plus 5, that is 5, 0 plus 10, that is 10. Okay. Now 1 has been selected. Now out of 2, 3 and 4, which is having the less distance factor, that is out of 10, infinity and 5, which one is least? That is 5. You will select this vertex 2. Okay. Now from 2, can you update any vertex? This one, this one, this one? No, we cannot update because there is no direct edge. Okay, this one is selected. Out of these 2, now we will select this 10 because 10 is less than infinity. Now from 3 to 4 we can update 10 plus 1, that is 11. Okay, 10 plus 1, that is 11. Now we have only this vertex. We will select this 4. Now you can update. Can you update this distance 4 to 2? No, according to the principle of Dijkstra algorithm, you will not update this one because 2 has already been selected. 2 has already been visited. Okay, but suppose you are updating this distance. अगर आपको update करनी है, then what would be here? See, from distance of this one is u, this one is v. Distance of u is 11. 11 minus 10, that is 1. Okay. If we go from 1 to 3 to 4 to 2, then the distance would be 1, and 1 is less than 5. Fine, but we cannot update here only. Why so? Because 2 has already been visited, and according to Dijkstra algorithm, a node which has already been visited, we cannot update the distance of that vertex. So Dijkstra algorithm in this case is having the wrong shortest distance, because according to Dijkstra algorithm the shortest distance from 1 to 2 is 5, but that is not actually true. The shortest distance from 1 to 2 is 1, through 1 to 3 to 4 to 2. So that is the main problem of Dijkstra algorithm. See, that is not always true. Sometimes maybe, suppose that if suppose this one is -1, let us suppose I am changing this one is -1 now. Now the distance is 11 minus 1, that is 10, and 5 is less than 10, so this one is right. Okay. So Dijkstra algorithm drawback is it may or may not work when it have negative edge weights. Okay, but it will surely not work when it will have a cycle which is having negative weight. Okay, negative edge होगी only. In that case it may or may not give the correct result. ये correct result दे भी सकता है, नहीं भी दे सकता है, but in case graph में एक ऐसा cycle है which is having negative weight, total edge weight of that cycle is negative, then surely it will give you incorrect result. Okay, so okay, I'll see you in the next video. Till then, bye bye, take care.